Okay, so good morning. I just wait for you here so that you can join me. Okay, so but still I see that not many of you are here. Hopefully you don't have any problems connecting to YouTube. Okay, so let us give time to others to join. This is the problem, so I don't start teaching now. First, I want to solve this problem which was left from the previous session. And I think it's also good to know about these type of problems as well. Okay, so the question is, determine A and B. They are constants in your function, such that the point 1 and minus 1 is a local extreme point of the function. Okay, so this type of problems are also different types of problems that you might face in this chapter. Okay, so one thing we need to know is that we know that this is going to be a local extreme point. First of all, I have two unknowns. So somehow I need two pieces of information to be able to answer this question and find A and B. Yes. One piece of information is clear. Because when you are saying that this is a point, this point is supposedly a local extreme point for this function, it means that this point lies somewhere on the graph of the function. Yes, that's the meaning of being a local extreme point. That is a point on the graph. Whenever you have a point on the graph of a function, okay, this means that the coordinates of that point will actually satisfy the equation of the function. So I would say that 1 minus 1 is a local extreme point. This means that 1 and minus 1 lies on the graph. On the graph of the function. Yes? And this implies that its coordinates will satisfy the equation of the function. So it means that if I replace x with the x coordinate, the value for the function is supposed to be equal to the y coordinate of that. So this means that minus 1 is equal to a times 1 to the 4. I'm replacing x with 4. And then plus 1 times 1, b times 1 to the 3. But if you don't mind, let me write it the other way around. 1 to the 4, 1 to the 3, both of them are 1. So I will get a plus b. And I have it equal to minus 1. But as you see, this is not enough to solve this problem because I have two unknowns and just one piece of information so far. Okay, and then this is something that you need to know. If this is going to be a local extreme point of this well-behaved function, a continuous differentiable function, it means that the derivative, it means that the tangent line at that local extreme point has to be a horizontal line. And it means that its slope is supposed to be equal to 0 at that particular point. On the other hand, in the previous chapter, we learned that if I want to find the slope of the tangent line, I need to differentiate the function and then replace x with the x-coordinate of the point of tangency. So by reading this, I would say that again, from the same piece of information is a local extreme point. Of course, let me write it, even though in your lesson this is always the case, of a continuous and differentiable function. You don't need to be worried about that, but just I mentioned this for the people who are actually interested in details. Of a continuous and differentiable function, f of x. So this implies that f prime at 1 has to be equal to 0. So again, I'm using the piece of information in a different way. So by reading this, I understand that f prime of 1 is supposed to be equal to 0. So then I have to calculate f prime of 1, but we know what to do. We are supposed to differentiate the function, replace the x value with the x value here, and then equate it to 0. So let me just calculate f prime of x first. So this is a very elementary calculation. So 4 goes down, and then I will have 4ax to the 3, and then plus 3bx squared, yes? And then what is f prime of 1? F prime of 1, I have to replace x with 1 everywhere. So let us do it in our head. 1 to the 3, 1 to the 2, both of them is equal to 1. So this becomes 4a plus 3b. Okay? So this is the f prime of 1. But I know that f prime of 1 is supposed to be equal to 0. So if I give it a name, number 1, and this one, number 2, comparing number 1 and number 2 implies that 4a plus 3b is equal to 0. So, and then everything hopefully is in order, yes? I have two unknowns, a and b, and now I have two pieces of information. And in principle, this is a very elementary problem now. So I will set up a system of equations. A plus b is equal to negative 1, and then 4a plus 3b is equal to 0. And I have to solve this system. It depends how do you want to solve the system. Here I prefer to use elimination method. So I keep b, I move a to the left, to the right. It becomes minus 1 minus a, and then I replace it here. So this will give me 4a plus 3 times b, which is minus 1 minus a, is equal to 0. And I can simply solve this equation. Minus 3a is equal to 0. 4a minus 3a is just simply a, and I move this negative 3 to the right-hand side. Finally, I was able to calculate a. Okay? And then I put it in this equation. So b is equal to minus 1 minus a, which is minus 1 minus 3, and that is minus 4. So b is minus 4. So this is a type of questions that I saw it is in the book. So you also need to understand what's going on. Okay? So if you want, of course, it is not demanded in the problem, but if you want to understand the nature of this local extreme point at this point, We will learn a little bit about the second derivatives test later. It would be easier for this problem. But even at this stage, you still can do that, yes? So now you put 3n minus 4 back into your function. So here, the function that you are facing is this function a, which was 3x to the 4, and then I have minus 3. B was minus 4. Minus 4x to the 3. Yes? So what you need to do if you want to determine the nature, so we can also add that part to the question, even though it is not there yet. So if I want to do that, then it becomes 12x to the 3 minus 12x to the 2. And if I factor 12x squared out, then what I get is x minus 1. So that would be the derivative of my function. And at that point, you don't need to set up the whole table here if you are supposed to determine its nature. So you don't need to, only if you want to determine its nature. So the numbers that you are confronting is actually, if I equate this derivative to 0, I get two answers. One of them is 0, the other one is 1. But here I am just talking about the 1, so I don't need to construct the table, the sign table in its entirety, yes? What I do, I just write x equal to 1 here, and I would say that, okay, here is my derivative, and then at this point, the derivative is 0. What is the value of what is the sign of derivative when x is smaller than 1? By the way, this is so simple that you don't need to even put random points here, because 12 is always positive, x to the power of 2, because of even exponent, it's always non-negative. So I don't need to be worried about this part. And it is clear that if I choose a number smaller than 1, then this becomes negative, and then suddenly the whole expression becomes negative. And this one, if x is greater than 1, it becomes positive. So this goes down and this goes up. So this point, which wasn't mentioned in the problem, which type of extreme point is that, we realize that this point is a minimum point. So you can detect. And I just want to tell you, if you want to detect, you don't need to spend time to solve the whole problem, because you're only interested in that particular point in this problem. Okay, so this is what was left from the previous session. Today, as you see the title of the lesson, graphing a function using derivative, or I would say its derivative. And then we already talked about that, I believe, when I was just setting up a table. But this is a topic in the book. I just want to spend some time on it, and then the lesson today will be finalized. And the next week, we will start a more interesting problem. We want to discover another property of curves using the notion of derivative. Okay, so today's exercise, I want to solve some examples for you. So more or less, you know everything. So you need to set up your sign table and then use the information in the sign table. By the way, I forgot to say, is there any questions here for this problem? Yeah, please don't hesitate to interrupt me whenever you don't understand something. Okay, so here, I will start with example. Okay, so here I have seen two types of problems in the book. Sometimes they ask you to sketch the graph. We cannot, of course, precisely draw the graph. And the goal is not that. The goal is just to capture the main properties of the curve. Okay, so meaning that we need to respect the way that the functions look like at terrace points and at local extreme points. Other than that, we cannot be very precise. And that is, of course, enough. But that's the main geometric properties of the graph of a function that we want to discover. Yeah, so if you don't mind, let me start with an example here. So example. So by the way, in the exam, I will, of course, this is one important part of this lesson. So then you will get a question how to sketch the graph of the function. And in that particular question, you are not allowed to use your calculator for drawing the graph, okay? You can use your calculator for calculating numbers that you are supposed to calculate within the problem, but you are not allowed to use the calculator to graph the whole function. You have to differentiate the function, equate it to 0, I don't know, set up the table. All these processes have to be done when you are just dealing with these kind of questions. So a sketch the graph of the following functions. Of course, let me emphasize by setting up a sine table. Even if I don't write this for this question, I always mean these. So, yeah, this would be a little bit hard to draw it on the board, but hopefully this will work. So x to the 3 minus 3x to the 2 minus 9x plus 5. Okay? We want to sketch the graph of this function. Sometimes they will provide you with an interval here. For example, they say that sketch the graph of this function when the values of x is limited between, say, 0 and 5. Okay, I will also give you some type of that example. I saw this in the book. But let us just forget about that for the time being and try to sketch the whole, have an idea how the whole graph of the function looks like. Okay, so if this question is given to you, you don't need to, so you have to follow everything that I told you so far for setting up the sine table. So meaning, if you remember, the first thing that I have to do is to differentiate the function. Here it's easy. So it's 3x squared and then minus 6x minus 9. The second step is to equate that derivative to 0 and find the possible roots. So this gives me 3x squared minus 6x minus 9 is equal to 0. So for simplicity, all of them are divisible by 3, so I decide to divide by 3 to work with the smaller numbers. So this becomes x squared minus 2x minus 3 is equal to 0. You can use PQ formula or ABC formula, but I think now you are in the 3rd grade. Hopefully you haven't forgotten what we learned in chapter 1. You can factorize this because these numbers are so famous. Finding two numbers whose sum is -2 and its product is -3 is very easy. So I think this is the fastest way to solve this. I open 2 pairs of brackets, and then I'm asking myself, I need 2 numbers whose sum is equal to this number and whose product is equal to this number. So I myself always start from the product. 3 can be written as 1 times 3, no more than that. Of course, there is a relation between 1 and 3 and -2, but I need to adjust the signs. Of course, the product is negative, so one of them has to be negative, the other one has to be positive. On the other hand, the sum is also negative. It means that the bigger one, from magnitude point of view, should be the negative one. Yes, so this means that one of them is -3 and the other one is +1. Always double check this. The sum of these 2 numbers is exactly -2 and the product is exactly -3. So that's okay. And then I put it equal to 0. This is not mandatory, by the way. You can use PQ formula to solve that. Okay, I get 2 answers. One answer is that when this is equal to 0, it means that x is equal to -1. And the other answer is x is equal to 3. So let us put them in a box. Okay. For drawing the graphs, when you want to sketch the graph, even though it is not necessary, but I recommend you to put x equal to 0 as well. I will tell you why, okay? But you don't need to write it down. I will put it in the table. This was not mandatory before. We just put, even still it's not mandatory, because my goal is to sketch the graph. If I can do a better job, why not, okay? And giving extra points will give me this opportunity so that I can have a better form of my graph. That's it. But if you don't respect that, that's okay. Okay, so I will start setting up my table. Do you think that I can fit it here? Yes, I think we can. So let me draw the table. Might be that is confusing for you. Okay, so I will do it later. So just do the set up the table as usual. X, F prime, and F. Yes. So there is no interval given here. So it means that I am interested in all possible values for x. For this function, the domain is R. It can accept every possible value. So it goes from minus infinity to infinity, yes? And then the numbers that I got are these two numbers. I arranged them in order here and there. And of course, no surprisingly, these two should be 0. I myself equate the function to 0, and I got these two answers. It is clear that if I put these two answers, I will get the 0 for the derivative. And then I will also need to find these numbers, but this row, let me repeat it again, this row is the F row. So I have to put in these values, not in the derivative, in the function itself. So you go to scratch paper. Okay, this is the part that I told you that for this question, if you want, you can use these scratch paper work with your calculator. But drawing the whole graph should be used using this table. Okay, so I go to scratch paper. I calculate f of minus 1. This means that I replace x in my function everywhere with minus 1. Yes, and then this becomes minus 1, positive 1 times negative 3, negative 1 times negative 9, and then plus 5, so it becomes 10, yes? 14 minus 4 is 10, so the number that I have to put here is 10. Okay, so hopefully this is not a very super big number. Let us see. F of 3 is equal to, I put 3 here, so then it becomes 3 to the power of 3, minus 3 times 3 to the power of 2, and then minus 9 times 3 plus 5. So it's a little bit unfortunate here, yes, because these two numbers are canceled, so it becomes minus 22. Anyway, that's minus 22. So the range is 32 units on the y-axis. But yeah, we want to sketch the graph, as I told you. Don't worry about those parts. Okay, so what happens here? This part is not the part of your lesson, but it doesn't mean that you don't understand that, yes? You see that there are some numbers going on, but when I want to make x very, very big, even though these are also become big numbers, but this will dominate because it's more powerful because of having a greater exponent, yes? So what happens if I put negative infinity? I can ignore them and see what this will tell us. So I have a very huge negative number. I raise it to power 3, it becomes negative infinity, yes? And if I put positive infinity, again, this will dominate, so I can ignore them compared to this one because it's much bigger. And then positive infinity to the power of positive infinity is positive infinity. I don't want you to write these things if you don't want to, so you just ignore them. But this is understandable. It's not something hard that you don't understand, actually. Because if you understand that, then you can immediately see that my function was minus infinity. The value of the function is minus infinity. Now I am at 10. So it is clear that I am increasing. Otherwise, how is it possible? I am in minus infinity. Okay, how can I go even lower? Yes. So from minus infinity to 10, it is clear it's increasing. From 10 to minus 22, it's decreasing. And from minus 22 to positive infinity, it's increasing. But this is cheating at the level of your lesson. So you need to actually consider the signs by choosing random numbers. But be careful. Random numbers, this is the derivative row. So you need to put the information in the derivative here. So please be, so sometimes I myself get confused and suddenly I said, okay, I'm just doing the very hard thing, because this derivative is usually a little bit simpler than that, okay? So I choose a random number -2. You don't need to find the exact value. You want to convince yourself about positiveness or negativeness. If I put -2 here, it becomes +12. And then -9 is +3. And this is also positive, so it is positive. So as I predicted correctly, it is increasing. Between -1 and 3, a good random choice is 0. If I put 0, 0, it's -9, it is negative. Again, it was according to our prediction. And then after 3, I can put a 4. So if I put 4 to the power of 2 is 16, 48. 48 minus 24, yeah, it's positive. That's enough. That information is hidden. You need to set up the table in a correct way. And then this goes it increases as we predicted. Okay, so this is the table. I need to set up these points. So that's actually a little bit annoying because these numbers are big. So I can increase, for example, you don't need to have the same scale on the X and Y axes, yes? So what you can do, you can just see the numbers are big numbers here relatively. So I decide to do this. I will change the scaling on the X and Y axes, yes? For example, I choose just normal units for 1 unit, but every unit on the Y-axis, I will take it, for example, 5 units, yes? So for example, I would say that I have, this is -1 here, and then I have 3, so this is 1, this is 2, and this is 3, so this is +3. Okay, but on the Y-axis, if I want to take each one of them to be 1 unit, I have to go 10 up and -22 down, so this would be boring. So let me take each 5 to be 1 unit. So for 10, I need 2 units on the X-axis, so I will consider this to be 5, and I will consider this to be 10. This would be, for example, 15, and etc. And then I will need 4 of them. 1, 2, 3, 4. This is -20, and the other one is -25, for example. I don't know which way I need to write it down. I will clean it if I face some problems. And the first thing that you need to do is to find the extreme points, locate them there. So -1 and 10 is a maximum point. You see, this is a maximum point, and this is a minimum point, yes? So -1 and 10. So this is my point. Let me change the color. So -1, yes, and 10. This is my point. So if you don't mind, let me clean this 10. Yeah, that was better if I draw it on the other side. So let me just write one of the numbers that we need. So this is 10. So this is the point. But what type of point is that? It's a local extreme point. So local extreme point means that around this point, the function should look like this, either narrower or wider. We don't know, but at least it looks like this, around that point. And then I go to the other one. This is a minimum, local minimum point. It is x coordinate is 3, the y coordinate is -22, yes? So here, again, this is exactly the other way around. Okay, so this is 3, -22 is somewhere here. This is -20, -25. You don't need to be very careful about these things because at the end of the day, we cannot draw the precise picture. And then if you don't mind, let me just clean this extra piece of information that we don't need. I can write just -22 here. And then this is a local minimum point. So it means that around that point, the function should look like this. Yes? And the important thing is that this is the power of derivative. You see, this calculation guarantees that nothing interesting is happening between them, which was not clear if I want to do random points. Yes, if I want to choose random points and find them on the graph, it is not clear that, okay, what is the behavior of the function between them. Of course, exact behavior, you have to locate every point, okay? But we see that nothing interesting happens for the graph of this function. The important, interesting points are these points. We locate them. So it should be a smooth, continuous, differentiable curve because that's a polynomial function. Okay, and this is my advice. Usually, I myself prefer to put x equal to 0 into the function because it will tell me where the function intersects with the y-axis if I put x equal to 0. I'm not demanding put y equal to 0 because most of the time we are not able to solve it. If I put y equal to 0, I am facing a third-degree equation. Might be it is not possible to solve it at all analytically, or even if it's really time-consuming, it doesn't worth it. But putting x equal to 0, almost always it's possible. So I myself prefer, even though x equal to 0 is not here, I add one thing, let me write it with blue. I myself put x equal to 0 and calculate the value of the function. It becomes 5. So this means that the point 0 and 5 should be on the graph. It will help me because you know that if I want to go from here through here, might be I pass through the origin. Who knows? Because I'm just doing something carelessly, yes? But this tells me don't do that. Because if x is 0, y is equal to 5, so it means that this point is also a point. This is 5. This point is also a point on the graph. This is the reason that I am asking you to do this, but for having a better picture. Yes? Now it becomes clear. This should be a little bit probably wider here so that I can go to this point. Yes? Okay? And then everything becomes clear. You see again, I don't know where to intersect with x-axis. If I want to know exactly that, I have to put it to equal to 0 and solve the solutions, which is not at the level of your lesson. So just do it randomly, okay? So you just go from here to here. And then again, this goes up. And from here to here, it is supposed to go down, yes? Because when x is minus infinity, y is also minus infinity. If I want to locate minus infinity, it means that in the x-axis I go to minus infinity and the y-axis I go to minus infinity. You see, then I will go here and then I will go there. Of course, you can see now the weaknesses, some weaknesses of my drawing. The weaknesses is this. If I take the coordinate axes away, I wouldn't say there are weaknesses. Because this blue curve that you see here captures the whole essence of this function. The reason I would say that this is not very precise because exactly I don't know where these points are located. Who knows? Might be this point is a little bit here. If that is the case, then it should go more steeper down. You see, it might be like this. And I don't know, it might be like this. But again, the general feature will not change. Of course, I have a better picture to reality, but this is more or less the same function. This is not possible to do it with hand, okay? So if I want to do that, I have to solve this one equal to 0. But at least I can say something about this function now. If I ask you, for example, f of x equals to 0, by this drawing, even though it's not precise, by this drawing, I'm asking you, how many roots do you expect for this? You can immediately answer. You can say because, according to this graph, even though it is not precise, but it captures the essence of the real graph, I have 3 intersection points. So sure, This has 3 roots. By the way, don't take it for granted saying that because this is the third degree, it should have 3 roots. No. For example, the function x to the power of 3 minus 1 is also a third degree function. But if I put it equal to 0, what I get is only one answer, x equal to 1. So there is no guarantee that if this is third degree, I should have 3. So I knew about this. Why should I bother to draw the graph? You don't know. According to the fundamental theorem of algebra that I was talking about in the first chapter, this function can at most 3 real roots. This is guaranteed. But if it is 0, if it is 1, or if it is 2, or it is 3, we don't know. By the graph of the function, we know that this is 3. By the way, we can know something better, so we can say something more. At least about this root and that root, I know something. I know this root is definitely greater than 3. How much is greater, this graph doesn't show me. And I know that one root is definitely smaller than minus 1. Unfortunately, about this root, what I can say for sure is somewhere between minus 1 and 3. And even from this picture, I can do it better. I can say it's between 0 and 3, but not more than that. I cannot. So I can extract some information regarding to my function using the graph of the function. So you see that everything is nothing is new except using the information here to draw the graph. And I would recommend you to do it all the time. Put x equal to 0. Sorry, not here. Here. Put x equal to 0 and find y, even if 0 does not appear in your solutions. Okay. Any questions? Is that clear? Okay. So now let me give you another example. This example, let me choose an interval. So this is one type of the problem in the book. There are no intervals, and sometimes they give you an interval and they ask you draw the graph within that interval. Yes. So let us just do one of those examples, and then we can finalize the lesson today. As I told you, this is I didn't know that this is in your book. So when I was teaching the sine table, I also somehow taught about this. I thought that this should be in Math 4. Then I realized today that this is also one part of your lesson. So it is good to know about this today, and then we go to the next important lesson next time. Okay, so let me give you another example. F of x equals to x to the 3. Yeah, we can add one more example. So let us see how it goes. X to the 3 minus 6x squared, and then plus 5. The interval given is minus 2 less than or equal to x less than or equal to 5. So more or less, this is the same problem. But what I want to do, I want to sketch the graph of this function. Let us just start doing this quickly. The first thing you know, probably, I have to differentiate the function. So it becomes 3x squared minus 12x. I equate it to 0. And then I get 3x squared minus 12x equals to 0. And what I do, I take 3x out. It becomes x minus 4 equals to 0. Yeah, this is simple. So either the first one is 0, which gives me x equal to 0, or the other one is equal to 0, which gives me x equal to 4. But something is important. Before accepting them, in this particular case, you need to check them against your interval. If they are within your interval, you accept them. Otherwise, you just simply ignore them. Okay, so this is crucial here. If there is an interval, be careful not to use all of them if they are not within in your interval. But here in my case, both of them lies actually on the interval, yes? So I accept both of them. And of course, one of them is 0, so I have to take care of the 0 case automatically, the one that I wrote with blue here, if you remember. Okay, then I can go to this table, setup table, but be careful here. It goes from not minus infinity to infinity. I have to write -2 to 5. Yes? And then I arrange these numbers as 0 and 4. So of course, here is f and here is f prime. No surprisingly, these has to be 0. And then I calculate the value. Oh, sorry. This is f prime. This is f. So here, I put 0 into my function to write the information here. When I put 0, this is gone. I get 5. And then I put 4 here. You can do these things in scratch paper. If I put 4, it becomes 64 plus 5, 69, and then minus 96. Yes, let me just do it in a scratch paper, not to mess up. So here I go here. Let me just write it here. So I put 4 there. It becomes 64. 4 to the power of 3. 4 to the power 2, 16. Times 6 is 96. And then I have a plus 5. So this is 32 negative, so it's minus 27. Yes, so that is minus 27. Yeah, that's unfortunate, actually. Yeah, these numbers. So you need to learn how to rescale them, yes, on the y-axis. You don't have to use the same scale. But here, if you remember, for the case of minus infinity and infinity, I told you this is optional. If you don't want, you can just ignore them. But when it comes to the interval, these are numbers and you can calculate them. So you put these numbers into the function and find these answers there. So again, I go to scratch paper. I put -2 into my function again, you see. So it becomes -8, -2 to the 2, positive 4, minus 24, and then positive 5. Is it the same number? Do you also no? This is positive 5. So that, yeah, that's again the same number. So it becomes minus 27. I want to double check it again. So if I put 4 here, 64, 16, 96, and 5, and then it becomes 69. Yes. So it is minus 32, yes. And here, if I put -2 here, it's -8, 4, minus 24. Yeah, no problem. That's minus 27 again. But I just wanted to make sure that I am not making mistakes. And finally, if I put 5 here, it becomes 125. 5 to the power of 2 is how much? 5 to the power of 2 is 25, times 6 is minus 150. And then I also have a 5. So it becomes minus 25, it becomes minus 20. Yes. So this becomes minus 20. Of course, here, this is even you don't consider this as cheating, because I was minus 27 and I have reached to 5. It's clear that I am increasing. It's not possible to decrease from minus 27 and reach to 5. And from 5 to minus 27, I'm definitely decreasing. And from minus 27 to minus 20, I am increasing. But let me just double check by using that. I pick a random point between 0 and minus 2, but here I have to use the derivative. Be careful about that. This is your derivative. So if I pick a random number, let us say -1, and I put it here, it becomes positive 12, positive something. Finally, it becomes positive. So it means that the function is actually increasing. And between 0 and 4, let us choose 1, for example. If I put 1 here, 3 minus 12 is negative, so it is decreasing. The prediction was right. And after 4 and 5, this is a little bit unfortunate if I want to put something there, but I can do some trick, yes? If I don't have calculator, I can factor 3x out. From here, I am left with x. From here, I am left with 4, yes? And now you are telling me that x is greater than 4. If x is greater than 4, definitely this part is positive. This part is also positive when x is greater than 4. If I multiply positive numbers, definitely it becomes positive, and this is also increasing, as we predicted, yes? And now you see that these are big numbers. So again, I want to use the same scale. On the y-axis, 5 units, 5 each unit, and then just normal one here on this axis. So let us see how this comes. So here, I will draw something like that. Here, because 0 was one of my numbers, it is automatically taken care of, so I don't need to be worried about that. So -2 to 5. So this is -1, assume, -2, so -3, and then let us go from this direction, 1, 2, 3, 4, and 5. So this is my 5, this is my -2, yes, and then first of all, you need to locate all your points, not only local extreme points. -2 and -27. Okay, so each unit, I'm taking it 5, yes? -5, -10, -15, -20, -25, -30. So this is -30. 1, 2, 3, 4, 5, 6. Yes, that's correct. And then okay, so all of them are negative actually, so that's good. So -2 and -27, this is not a particular point, that is just your final end point on the left. -2 and -27. So -2 is here, -27 is down there somewhere here, for example. So this is the end point, so you need to put a filled dot. If this interval is like that, then you need to put a hollow dot, showing that you are excluding that point. But here, I have written here, so I put a filled dot, meaning that I am including the left end point. And then I go to the next point, 0 and 5. So x is 0, y is 5. So 5 unit is here. X is 0 and y is 5. So this is my local extreme point. So I would recommend you to draw your guide here. So it should be something similar to this here. Okay, or it might be wider or narrower, we don't know. These are not important. So 4 and -27. So this is 4, and I go to the same point, but this is a local minimum point, yes? So this is the local minimum point. So it means that around this point, the graph looks like that. And then finally, 5 and -20. So -20 is here. Again, you have to put a filled dot. Okay, so then you start drawing the graph of the function. Just sketch the graph, but be careful. You are not allowed to extend the graph beyond the interval. That would be wrong. This is the dead end from the left, and that is the dead end from the right. So you need to respect that. And then, of course, unfortunately, if I want to find the exact value, I should be able to solve this problem. By the way, this is easy, not hard. If you like factorization, you can put this equal to 0 and use factorization to solve this equation precisely, but that is not needed. So here, I just ran, I don't know, this is the best that I can do. And then I go here, yes, and then I go here. And I have to stop. I am not allowed to extend the graph beyond that. So let me make this black one. This black one is the graph of the function. Whatever you see is the information to use to draw the graph of the function. This is the graph of the function within this interval. Okay? I think we have a little bit of time. So far, if I'm right, I did another one so that you face a terrace point. But unfortunately, if you want to have a terrace point, you need to have higher order polynomials. Hopefully, we will not face any problems if I want to calculate these in my head. Okay, let us just do it. Okay, and let us see what will happen if I also have a terrace point. I will relax this, so let me just repeat. If one of these intervals, if one of these ends is exclusive, either that one or that one, you have to respect this and show that. Okay, so you put it in your table, even if it is excluded. Be careful. If -2 is excluded, you still put it in your table and calculate everything as before. The only thing that you need to be careful when you want to draw the graph, you have to draw this hollow dot. So instead of having that, just show me that you are respecting this. So instead of putting something like that, you draw something like this, meaning that you are respecting and you understand what's the meaning of this interval. By the way, this is also a name that I want to talk about that. It's not mentioned probably in the book. If an interval is like that and it is inclusive at both endpoints, this is called a closed interval. A closed interval is an interval like this. And we also have an open interval. It means both of them are exclusive. X is this one. This is open interval. It's good to know. If you take a math book, if they are talking about this, you understand what this means. And we can have half open, half closed. Yes, sometimes people call it half open. If one of them is closed, if one of them is inclusive, the other one is exclusive. Or people call it half closed. Yes, it doesn't matter. Okay, now let me start another example. Hopefully we can solve it on the board. I do not have any calculators here. Might be you can help me from home, prevent you from sleeping. I don't know the situation. Sometimes it seems that I am getting crazy talking to myself. Hopefully you are listening to me there. Yes. Are you? Hello?
Yes, we're listening.
Okay. We're listening. Okay, good. This is sometimes, for me as human, is necessary, okay? Otherwise, I would say that, okay, am I crazy, you know? These days, I'm always in front of the camera, either teaching or recording, so I'm thinking, okay, sometimes I'm getting crazy myself, you know? Okay, so let us solve another problem. F of x equals to 3x to the 4 minus 16x to the 3 plus 24. I don't know why I designed it with those numbers. Might be I don't know. Let us see how it will go. Yes, these numbers are actually big because I want to have a function with higher degree so that you can also see what happens if I have a terrace point. Yes, hopefully this is a good example. So let us start with doing that. The first step is again clear. I take the derivative, it becomes 12x to the 3 minus 48x to the 2 plus 48x. So this is my derivative. And I want to equate the derivative to 0. Okay, so this is a third degree polynomial, but solving it is easy because I have intentionally designed it in a way so that you can see I can immediately pull something out and it becomes a first degree and a second degree equation and you already know how to solve them, yes? So if I put this equal to 0, by the way, if you don't mind, for the future, so that the calculations become easier, let me factorize here. I factor a 12x out. And then what is left from here is x squared. And then from here, minus 4x and plus 4. And by the way, I can simplify it more. So yes, my example is correct. So this becomes 12x. This is These are not necessary, but it is, of course, it facilitates a lot if you see these patterns. This is what? This is a complete square, so I can write it as x minus 2 to the power of 2. Okay, so now it is easy now. If I put this equal to 0, it means that 12x times x minus 2 to the power of 2. Whenever you factorize, it is very helpful for that step that I want to design to determine the sign using a random number. If I have it in this form, it's easy. I don't need even to check about the random numbers, especially if I have an even power. So I know that this part is positive. The sign of this only depends on the value of x. If x is positive, the whole combination is positive. If x is negative, the whole combination is negative. So if I put this equal to 0, then either this is 0 or that is 0. If this is 0, x is equal to 0. And here I don't have any interval, so I don't need to be worried about if this is acceptable or not. And then I go here, x becomes equal to 2. Okay, and then I start setting up my table. So the table is x, f prime, f, and then it goes from minus infinity to positive infinity. And then what happens here, I have two numbers, 0 and 2. Not surprisingly, these numbers have to be equal to 0. And then I put these numbers in the function row. This is the function row. So here I put 0. Okay, good. 0, 0, 0, minus 9. It was super simple. And then I put 2 here. So let me go to scratch paper and put it 2 here. So I don't think the numbers are quite bad. So if I put 2 there, it becomes 16 times that, it's 48. 2 to the power of 3 is 8, and then it becomes minus 128. Okay, and then 4, 96, and then minus 9. So if I calculate this, it becomes minus 80, 16, 7. Yeah, it was simple actually. So it's 7. Okay, if you want to, I told you, if it is minus infinity, it's not mandatory to put these numbers there, but let us check, it's not hard. If I want to put minus infinity, the term that will dominate is the first term with the highest exponent, so I can simply ignore these things with respect to the largeness and this largeness of this one. And then I put minus infinity there. So minus infinity to power 4 is still a huge positive number. Multiplied by 3 is a positive, very big number. So positive, very big number. If I want to symbolize it, I would say positive infinity. And then even if I put positive infinity, clearly it's positive infinity. If I can determine these things, I really don't need to choose those random points, because from positive infinity, I have reached to negative 9. So it means that definitely I have decreased. And then from minus 9 to 7, I have increased. And from 7, I have gone to positive infinity. Again, I have increased. Okay, but let us not rely on that. Let us go back and choose the random points here. But it is super simple if you have already put your derivative in that form. So if I go below 0, I told you that this part, because of this even power, is always non-negative. 12 is always positive. So if I choose x a little, even a little smaller than 0, the whole combination becomes negative, yes? And if I choose 0 after 0, this becomes positive, so positive. Even after 2, it is still positive, yes? Because if I put a number bigger than 2, it's positive, 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 it's positive. So our prediction was exactly correct. But now you see that one of these points is not actually an extreme point. It's not an extreme point, it is a terrace point. Okay? So that's also a good example so that you can have what happens if I have a terrace point. Technically, nothing different, yes? I'm just doing the same thing, yes? So here it's a local minimum, and that is a terrace point of this type. Increasing, because terrace point could be the other way around, but this is of this type. So I will go and locate the points as usual, but these numbers are relatively Good. So if let me just do the same scale on both of them. Yes. Here I go at the points 0 and 2. So one point is here, and then 1 and 2. This is good. And then I have -9, which is minus, let me choose the same scale. -1, -2, -3, -4, -5, -6, -7, -8, and -9. So this is -9. And then 0 and -9. Exactly 0 and -9 is this point. And then 2 and 7. So 1, 2, 3, 4, 5, 6, and 7. Okay. So 0 and -9 is a minimum point. So it means that the behavior of the graph of the function around this point should be similar to this. But this 2 and 7, that point, is a terrace point of this type. So it means that the behavior of the graph of the function around this point should look like this. Yeah. Okay. And then unfortunately, there is no extra information that I have, so I have to draw the graph. I know that if x is minus infinity, f is positive infinity. So it means that if I go to the left, very left, then the function value go very up. Okay, so it means that from somewhere here, I decrease to reach to this point. Okay. And then when I reach, I start turning around and go and reach myself to this somehow. Of course, this graph is probably, yeah, but this captures the essence, yes. And then after that, I still continue increasing. So there is no returning back. And this also confirms that, because if x is positive infinity, y is also positive infinity. So there is no going back. So this would be the form of the graph of my function somehow. So the only problem is that I really don't know exactly these values. If I want to know these values, what I have to do, I have to equate this equal to 0, even I don't know if I can solve it or not, okay? So you have to put it equal to 0 to see that if you can factorize that. But you see, if I ask you, even if this is not, this is a sketch of the graph, it captures the main essence of the real graph. For example, this is the 4th degree polynomial. If I ask you how many solutions are there for this in the real set, of course, in the set of real numbers, then you can immediately see that 100% we are sure that only there are 2 intersection points, because there is no returning back whatsoever. It doesn't matter how much I zoom in or zoom out, I will not get any returning back. So this is 100% we are sure about that there is only 2 real roots, even though the polynomial is a 4th degree polynomial. Yes? So this is the lesson, and I think it was not completely new. More or less, we did everything we knew before, but I just want you to understand this is a good lesson, because if you remember when I was start talking about these notions, I told you that it will help you to sketch the graph of the function. And I hope that you realize that this is no longer a simple function. Everybody knows about the function, the graph of y equals to x squared and things like that. But here, I hope that you agree with me how many points you want to randomly put in so that you can get these values. So for example, if you want to randomly put points into this function, randomly, and extract that piece of information, of course, you can locate some of these points. But who will understand by just random points that the behavior of the function around this point would be like that? Yes, even if you coincidentally detected this point, but how do you want to bend the curve? using that piece of information. I want you to understand this is a very powerful technique. Yes, we couldn't, even if by coincidence I come up with these points here, 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 there, how should I know that the behavior of the function around that point is like this, or it will bend something strangely here? Okay, so this is something that we couldn't do that, even if we were lucky and accidentally got those points. Yes, so I just want you to understand what we have done. Even though it seems a little bit tedious, I want you to understand this is not something that we have done for nothing. Yes, we were not able to capture the essence of the real graph using points, full stop. Yes, but now we can. Okay, we couldn't, we can. So we are more powerful now. Yes. Of course, at the end of the day, you might say that I don't care about the graphs. That's another problem. Okay, but if you do care about having a good picture, this is it, not just random choosing of points. Yes. I hope that you don't have any big problems here. Everything is clear, and I am ready to answer your questions if there is nothing clear. Otherwise, I will end this live stream and I will go to Zoom if you have any questions until the lesson ends in 10 or 12 minutes. Any questions? Okay. Okay, so thank you very much for listening. Pardon?
I have to use the calculator to see where it's crossing the x-axis.
Yes, if you like to. Because that is not fun. Of course, calculators can give me this. The fun part is that if I myself can solve it exactly. And it is not that clear that all the functions, if you are interested in that, I have very long videos on my YouTube channel to say that how can you solve, or at least intend to solve these polynomial equations. I don't know, it is under the title of Factoring Polynomials Part 3 or 4, I don't remember. But if you see, I have talked about how to solve these problems analytically. So I don't know, for example, if you have GeoGebra available, you can use this, you can use GeoGebra to calculate that, and there is an intersection tool there, so you can just highlight that and point to these points. Calculator, a GeoGebra will give you some approximate value, but still, I feel that Alpha Wolfram is a very free tool. So if you go to Wolfram Alpha, and you just type this function in Wolfram Alpha, Wolfram Alpha will give you any sort of information that probably even a mathematician needs about this function. Yes, a lot of information. Yes, some of those informations might be useful for you, might be automatically. You don't even need to ask Wolfram Alpha to solve this equation for you. Just punch this there. I can test it after this video. I can end this video. You just punch this there and see that what information are there for you regarding this function. Okay? Okay. But if you want to, yes, that's not fun part for me. If the calculator wants to do this for me, there's no fun for it. The fun is myself. Is it possible for me to solve this analytically? And of course, I know that this is not always possible to get exact values. But there is algorithmic ways of factorizing these. So for example, one thing that I can understand here, I can understand that there are two roots for this function. So I will try to see that if I can factorize this. If I want to factorize this, because this polynomial is of degree 4, the factorized form should be a degree 1 multiplied by degree 3 or 2 degree 2s. Okay, so one way is to see, is it possible to factorize it to the power 1 and 3? But if I want to have it 1 and 3, it also might be possible, because the degree 1 has one single root. The degree 3 might also have one single root. That's also possible. But anyway, let us punch it in this Wolfram Alpha to see how it goes. So if you don't have any further questions, I can end this main stream. I'm still available in Zoom. Okay, thank you for listening.